A warm welcome to all. I'm Eugenio Fazio, a researcher at the University of Catania. Before starting, I would like to apologize for not being able to attend the meeting in person. I hope that in the future I can meet all the students and colleagues who come here today. However, ideally and thanks to technology, we are in contact, even if virtually. I would like to thank you very much, the Task Committee, and especially Manish for the invitation to give this lecture about drone survey in geological mapping. It is my great pleasure and honor to have this opportunity. The presentation is divided into three parts. In the first part, I will tell you about the drones and aerial imaging. In the second part, I will briefly show you the basic principles of aerial photogrammetric techniques, flight mission planning softwares, three-dimensional models, and virtual outcrops. Finally, in the last part, I will give you an example of the application of the use of aerial surveying with drones applied to a regional crustal scale shear zone of southern Italy, recently studied together with some colleagues of mine. In this first part, I will give you some basic information about drones and basic techniques of aerial photography. I will tell you briefly about the strengths and weaknesses of the use of drones for photogrammetric surveys and the reason why they are excellent tools to support the fieldwork during geological surveys for mapping areas, especially if difficult to access. Drones, or UAVs, unmanned aerial vehicles, are essentially of two types, multi-rotor or fixed wings, all have in common a global positioning system, an antenna for communication with the pilot's radio control, a camera in the visible range for image capture. The size, weight, technical characteristics, flight duration range can differ greatly from model to model. It is now common to mount on the aircraft a series of different sensors depending on the intended use and purpose of the project. The various models of drones reflect price ranges, but today you can start without spending exorbitant amounts of money to fly and get reliable results. The sensors carried on board will certainly have an influence on the overall costs, remembering that sometimes for accidental malfunction or external causes, bird strike, unexpected collision, strong wind, lack of stable communications bridge, the whole equipment could be lost irremediably. Moreover, only properly trained operators can use drones in compliance with their rules enforced in the various countries where the mission is carried out. The aerial survey with drones is located, as can be seen from the diagram shown here on the right, between the photogrammetric terrestrial survey on one side and the aerial photography techniques with pilot on board or acquisition through LIDAR on the other side. It should be noted that there is an overlap with manual measurements, for example orientation of geological structures obtained from the compass, and this is an important link for our purposes. The areas that can be investigated with drones, shown on the left figure, vary from a few square meters for detailed surveys, for example useful to obtain information on vertical slopes, to several square kilometers for larger areas, generally flat, from variable heights up to a maximum overflight altitude of about 3 kilometers. This is a very unusual example of mapping an entire summit, the Matterhorn or Cervino, with drones, depending on which side of the Alps you are looking at the peak, from the Swiss or Italian border. The project dates back to 2013, was led by SimsFly, belonging to the Parrot company, and with the support of several other companies involved for the technical and logistic support, it has been successful. A three-dimensional model with high density of points of the entire mountain area has been reconstructed. For these reasons, the drone is a very valid aid for routine operations that a geologist often conducts on the ground to collect data, and it also represents a valid support to plan in a targeted way the collection of rock samples, avoiding waste of time and energy. You can see here a high-density 3D point cloud model after 11 flights and more than 5 hours of flight time, mosaicing more than 2,000 pictures, and but the result is really amazing. This is a comparison between three different techniques of reconstruct surface from a 3D object like an outcrop, and as you can see on the left, the LIDAR gives accurate and high density results of the model with a coverage of about 17%, better with terrestrial imaging by photo cameras put on the ground, but in this case the fitting between the derived mesh and the manually complex made measurement is really bad. Instead, with the drones, the right model, we have the greatest coverage, nearly 100% of coverage of surfaces, and most importantly, the mesh and fit very well the manual measurement made by compass. This is a table which compares photogrammetry and LIDAR techniques, and as you can see, costs are sensibly different, being very expensive for the LIDAR sensor, and but of course depends the aims of your project, but as you can see, the accuracy is comparable between the two techniques. Drone must follow some air rules, and so it depends where you are planning to do a mission. You'll be aware of restrictions of critical area that cannot be fly for several kind of reasons, military bases or something else, and you have the control. Only the pilot should fly with the responsibility. In Europe regulation, there are several categories of risk, and it is necessary that the pilot follow a course for to fly in different scenarios, especially if people are involved in the scenario. Drones are very multi-purpose devices because they are used in a lot of different branches of acquiring images from the top, and they are developed first in the military industry, and then it has grown in different fields of investigation. But I think that the important thing is that this device is very useful for geological mapping too. Of course, you have to pay for another bag with another device, except of your compass, your hammer. You need a small bag, an extra bag with this device, which is not so heavy, but of course, another backpack is in the list. It nevertheless gives you a new perspective, point of view, which could be interesting, useful during field operation in various kind of situation and scenery. The use of drones in geological mapping have, of course, some strength points as well as some critical ones. You can see here a list of them, but essentially the increased portability and decreased cost allow having more people can access to this technology, and the results are very good, and the safety, especially in difficult access areas, is really improved. And data that you acquired by drone can be compared to other datasets you collected in the field. So for a geologist, drones are very useful because allow you a fast examination of an area. So you can have another perspective of the field. So you can save a lot of time avoiding to go into an outcrop. You can just have a quick view by remote controller of very large area around you. So you can also plan a strategy for sampling, for where doing measurements or by your compass, or where you take samples. So it is a very useful, especially in the first approach to an area. And of course, safety is also improved. Okay. Surveys made by drones are usually of high resolution, images are georeferenced, and you can extrapolate 3D elevation models. You need, of course, some software, and we will talk in the second part. But at this time, I would like to show you some application, because various branches of geological science could benefit from this use of drones, from geomorphology to structural geology to engineering geology and so on. So I will show you some case studies. In volcanic areas, drones are very useful to monitoring lava flow, like recently in Hawaii during an eruption, but also after, in the quiescent period. You can also investigate new morphologies on the flanks of volcano, um, and you can map with a high accuracy the elevation of new lava flow channel, and it is a good tool. different scenario, like this one in Sicily, where there are not some cliffs, but subvertical, which span for a few kilometers. It could be very interesting to have the possibility to have a good point of view, not from the bottom of the slope, but in the horizontal position. You can see lamina strata, forested cross bedding, and also you can do a first level faces recognition, and also it is good to have a new point of view, new a different perspective, which are unique, and maybe only with a helicopter you can have a similar viewpoint. So I think that is a very powerful device, which allocate you a lot of time to do something else, rather than go around the area by walking. Well, in this second part, I introduce you some very basic principles of photogrammetry, and then I show you which kind of software I usually adopt to do my mission, and also how to reconstruct a 3D virtual outcrop and generate digital terrain models, and how to share your data into database. Here you can see a operation workflow from step 0 towards various steps. Following this line, you arrive to your output, and of course you have to make a first pre-flight fieldwork. You can select where takeoff or landing, where put your ground control point, and then you have to collect images and check quality of them, and then reconstruct through softwares a 3D model, where detection of matched features assigned to 3D coordinates will reconstruct a 3D network of matched points. In photogrammetry, the aircraft captures a larger number of shots over an area of interest, and then such images should overlap for at least 60, 70, 100%, such that the same point on the ground is visible in multiple photos from different perspectives. This is the similar way that the human brain uses information from both eyes to have a stereographic view. The result is an high-resolution 3D reconstruction that contains both information about the relief, the elevation, but also texture, color, which is very useful in the geological mapping. Then Nowadays, the aircraft drones are cost-effective, and so there is a new future for this, the application of these techniques in geological mapping routine work. So the basic principle is the capture of the same point by different point of view. The camera is moving and the 3D object is analyzed by different perspectives. The important thing is that there should be an overlapping between flight lines, parallel flight lines, recommended of 60%. This ensures that you have a good point correlation, the same point in both adjacent shots. There are a few points to be considered during an aerial survey. For example, the ground sample distance, it depends of course by the height of the shots taken during the flight, and it has an effect on the picture's resolution. Another point to be taken into account is the overlapping. Like in this situation, the relief have a different elevation with respect to the fixed elevation quote of flight, but in this case we have a good overlap between three images, and instead in this case we have a bad overlap. The field of view of your camera optics combined with your detector has also an effect on the ground sample distance you acquire in your final image in pixel. To the right here we have an idea of how works stereographic coverage between pairs of pictures taken at different heights but with different aperture focal length, which give the same stereoscopic coverage. Another aspect to be considered is a situation where the slope is very steep, and maybe it's better to plan a mission who follow the terrain, the relief, because sometimes it could be happen that in some areas there are not enough overlapping between adjacent shots. Ground control points are position of known geographic coordinates, and often they look like this one, and you put your eye precision device in the center of the square, and in this case this specific model is completely independent and is linked to your station, but sometimes it is useful to have also some benchmark from geodetic survey, which can also be used in your to constrain your coordinate frame and area. Basically, like is shown in this figure, that you need control points at the corner of your area if it is of regular shape, but also in the center and in intermediate position, as well as on the borders. This ensure a good quality for the entire area. So our aircraft has a connection with the satellites, which should be every time sustained, and the link should be at least 12 independent satellites, but you need also, for good accuracy topography acquiring, base station which is linked to your aircraft. This ensures the quality of the coordinates of the shots taken from the camera is good. On the right there is an example of an area surveyed by a drone. You can see how the control points are distributed along this river flow stream in a manner that cover almost all the area of interest. In such case, we have a classical ground control point, and an operator record the position with a global positioning system. There are different ways to acquire photos of the same area during a drone survey. This will depend on the purposes and expected results. The classic plan to cover the region of interest consists of a flight plan that follows the movement of the plow pulled by oxen in a field, such as the Bustrophoedic writing, that allows to take fixed interval photos on parallel rows to have sufficient lateral overlap, like this. Of possible mission is the circular mission, and I will show you briefly how this works. You can select on your radio controller the height, the radius of around a point of interest, and to have a circular perspective of a point of interest, which should be at the center of the scene, and this allow you to have a 3D model reconstruction. Okay, so we have a lot of different software for planning mission, and when you start your survey, you have to decide what kind of application use. I have listed here 4, but there are a plethora of different softwares who made this job. Personally, I've used Pix4D capture, which allow you to have good control on various setting mission, time, height, return to home of the aircraft if something goes wrong. But there are also very good alternatives like drone deploy or drone harmony, or DJI pilot, with differences, of course, but sometimes, for instance, Drone Harmony lets you to visualize 3D capturing volumes. So it could be nice if you, I don't know, analyze buildings or something similar. The common things of all this software is to set the flight parameters during planning, so the ground sample distance, the camera information, and of course during mission, to do good aerophotogrammetry is better to use autopilot mode rather than user human piloting, because it avoid positioning without good overlap between lines near. This is a comparison by Stefan. I suggest you to have a look to this web link because there are a lot of tutorials about drones and various kind of software and capabilities. And as you can see, there are several opportunities, several chances, and also different operative systems, different kind of missions, and different costs, of course. Okay, this is the application that I used usually is the Pix4D. You have to prepare your drone, connect your radio controller, and plan your mission on your smartphone if you want, or a tablet, or on a controller. So the cost is very low. Everybody can take this kind of task. You have all the information relative to the time of flight, the number of pictures needed to cover the area of interest. I show you the mission I've planned, and I personally use Mavic 2 Pro with Hasselblad camera with a sensor of 1 inch, which is a good accuracy sensor, and combined with Pix4D capture, and this I think is a good solution, at least for the beginners. So, but I must confess that this is a very good device in the field. I've selected one site who is a natural reserve of near my city, Catania, and is also supervised by my university. The site is a beautiful group of little islands near the coast, and where columnar jointing is frequent, and I would like to have a look to this object here, and from the top view, this is the area of interest, which probably Manish remember during his visit in 2011 in Sicily, and also for this reason I selected this site. Okay, this is a very rough sketch map with some geology. Basically, there are basalts. The first volcanic occurrence of the Etna volcanic system are related to this site, and you can see that basalts often erupted in subaerial or also submarine conditions. There are also below lavas in some outcrops, and the basaltic lava have been in contact with the overlying clays, here indicated with hay in this picture. So this is the contact between lava below and clays. There is also another formation on the top, which is indicated with C. It is only on this island. So in our case, we have only to study this Faraglione Grande. Okay, after image acquisition, you have to make a mosaic of the images, and you need a software to do this. Also, in this case, there are a lot of different choice. I used both Pix4D Mapper and Agisoft Metashape or Photoscan, but there are alternative software, Cloud Compare, Meshlabs, and a lot of other options. This is a comparative table of different software, but basically the process is the same. You have to add photos into the software, align such photos, control optimize cameras if is needed. Then in the second step you can start to build a dense cloud from the first sparse cloud, and then you can build mesh and texture applied to your 3D model. Then you can export in a lot of different file formats and share with others. Here are my shots over the stack, and as you can see, I've made three different circular missions around the point of interest at different height of flight, and I obtained in a couple of hours quite good results without control point. I never been on this site, so this is very preliminary results, but it could be of interest, of course, because it's possible to generate a digital elevation model and contouring the topography, and so it is anyway a good result. The software, in this case I've used Agisoft, give you some information, a report with survey data. You can see there are 107 images, flight altitude is in this case 81.5 meters. The ground resolution is above below 2 centimeters per pixel. The coverage area is very short, it is not so large, and there are various information about the error in the 3 directions, and the total error is quite high because I don't use any ground control point in this case. Again, there are also different kind of further information about the resolution, the point density of the final digital elevation model with all parameters used during the flight. And at the end, we have them with such information. Now we have a 3D model and we can export into a KMZ format, and this can be imported and opened by a very nice application, GeVis 3D, by Michael Roche from the University of Tasmania, which allow you to put geological structure orientation into your 3D model. I think that this is a very, very powerful tool for the geologists. Okay, in my model, I selected a lot of surfaces, and it is possible to see your selection in the equal area SerioNet on the top right corner, and you have all the information listed in a table. You can export, of course, this data set and play with different classical software of stereographic analysis. Apart of surface, you can also insert into the 3D model linear elements, like in this case, I've selected the intersection between the columns to have an idea how they are oriented. The long axis, in this case near subvertical, the green arrows are in the equal area SerioNet displayed. In this case, like an example, you can see a change in the orientation of the columnar basalts, and the orange arrow are dipping towards southeast, and you can see very good on the net and in the picture of the 3D model the changes in the orientation of linear elements. You can also put a ruler to make measurements like this, 7 meters, 30 meters from this point to this one, but also you can also have the opportunity to insert some planes, like the contact between basalts and clays, which are on the top, and this surface here is displaying the StereoNet, very, very subhorizontal cyclograph. And you can share your 3D model, and for example, I found on the internet this advanced project, a virtual library of Australia geology, the House Geo project, which is a very well organized website repository of 3D model documenting the different outcrops of interest in Australia. I believe the fieldwork is an essential part of the work of geology, but you can have also benefits from a 3D model, especially for students, because sometimes it's difficult to explore very remote areas, and it is possible also to avoid dangerous location and so on. Another example of a web repository is the HEROC website, where a lot of different kind of outcrops are collected and stored, and you can find at this web link that if you want to have a look to these models with another application, which is the Sketchfab, very used for sharing. And it is possible also to append supplementary data to your publication 3D model, so everyone can walk around your model, see textures, and also fly around and have a good 3D visualization. In the last part of the presentation, I show you a multi-scale investigation approach of a regional scale shear zone by focusing on a couple of outcrops. And we did also microstructural study, and we are now moving to the big picture. In detail, the outcrop I will show you is in southern Italy, in Calabria, where crystalline rocks outcrops. Variscan orogeny has been also affected by alpine orogeny, and this has caused strike slip tectonics in this segment of the acquired Calabria-Italy orogen, and the study area is in this point. The strike slip zone is more or less east-west oriented. Zooming this area, you can see that there are a shear zone which divide tonalize in the southern part of the area, the red rocks here, from migmatites and paragneiss on the northern part, the purple here. In between, there are calc-silicates, marbles, and which define this roughly east-west directed subvertical shear zone. The outcrops are also near the coast, and you can see from this picture the outcrop of the area. We collected samples on this area, we make thin section, and we studied micro-domain and coarse axis pattern. We established that subsimple shear was active in the shear zone, and we inferred a shear strain rate of 1.13 to the power of minus 11, and there is a lot of contrasting rheology between rocks involved in the shear zone. Pictures show you that the foliation is very steep, near vertical, and there are falls. This is the foliation. There are falls very near isoclinal. This picture comes from this part of the outcrop. So you need a boat to go to these stacks, which is funny, but sometimes it is also good to have an aerial view of the outcrop. This could be done by a drone. As you can see in this picture, the rheology contrast is very high between such rocks, but all of them are involved in the deformation, and tonalites, megmatitic, paragranites, and calcilicate and marbles react in a different way to this alpine. In this outcrop along the coast, it is possible to see a quite big fold. We seen this from the both, and it was difficult to arrive or study because it's near vertical surface, so it is very difficult to take measurements of structures by your compass. So we decided to have, also in this case, the help from an aerial view, and we build a 3D model. This is the result. Again, with GeVis 3D, it is possible to have an idea of orientation, of fold axial plane, of limbs of the fold, of the main foliation, which is in this case a myelonitic foliation. Again, you can select various kind of structures, linear or planar structures. You can add with your visual subjective interpretation, but of course you can also export and compare this data with the other data you have collected in the field. In this case, you can see the green planes are the limbs of the fold, in the purple is the axial surface, and in red there are like this and this one. There are some discordant dikes, and in the equal area stereo you can see such information. The panoramic view of the outcrop we study, as you can see, there are flat surface, but also some relief. So it is good in this circumstance to have a circular mission, but we also decide to have a multi-grid mission, like you can see in this point. This point is more or less this part of the outcrop in a aerial view. We did such kind of acquisition. We went to the field, we analyzed beautiful structures, and from the UAV we go through the virtual outcrop. In this case, we also collected images of the other stock, and we did our interpretation. This is the result of the model of our survey, and you can see a quite large model, and you can fly around and add your information. Like you see in this picture, we have a lot of foliation in blue dots, but also axial planar surfaces, which has been identified both in the field but in this case only by the model. There are the purple square in the stereo plot. Okay, we have also mapped by singular photograph the lithology. You can see here my end drawing interpretation, but the important thing is that, for example, this is the foliation here in this plot, and you can see a very good correlation of maxima like the ones I've showed you in the earlier slide. Also, it is most difficult to have information about lineation, which are more or less the stretching is oriented roughly east-west, subhorizontal. In this stereo plot, we have the fold axis, which have a maximum here and are dispersed around this best fit circle. So fold axes are rotating between the subvertical to subhorizontal position. Again, in our model, you can also correct your interpretation, go around again into the model and make some shifting or rotation around X, Y, and Z axis. The 3D model you can inspect by GeVis 3D is very realistic, and you can have an advantage to revisit the site in a virtual sense and potentially extract more useful data. I think that is a good opportunity, and maybe the future is in this kind of application. Drones are equipped with cameras and are give a powerful bird's eye view of the terrain, and so they changed our way to map geological unit, and I think that are valuable tools for a geologist. Uh, Nowadays, can be considered a low-cost alternative to the more expensive classical manned aerial photogrammetry, and in recent years the costs are very lowered, so it is possible to a wider audience and to users to go through this method. You can reconstruct a 3D model, especially the textured 3D model is important for a geologist to visualize the outcrop, again, the virtual outcrop, but of course fieldwork remains the cornerstone of a good geological mapping. UAV, in my opinion, is had a improve your model, but you need to start from the field. Okay, thank you. Thank you very much for your attention, and please make question if you want. I try to connect with you. Bye. Thank you.